so we have been talking about adding and subtracting using inequalities. We're going to move on to multiplication and division of inequalities. So our essential question we're looking at is, how do we use multiplication or division to solve an inequality? This first part is we're given an inequality. So my inequality is 4x is greater than 12. And what I need to do is fill in this table to figure out what my values are at different points. So I'm going to plug x values into 4x, this part on the left-hand side. So 4 times negative 1 is going to give me negative 4, right? And then what I want to do is I want to ask myself, well, is 4x greater than 12? So is negative 4 greater than 12? No, it's not. So I'm going to put no down here. Do the same thing for the next one. 4 times 0 is just 0. Is 0 greater than 12? No, it's not. 4 times 1 is 4. Is 4 greater than 12? Nope. Still not. 2 times 4 is 8. Is 8 greater than 12? Nope. 8 is still not greater than 12. 3 times 4 is 12. Is 12 greater than 12? My answer for this one is still no. Because 12 equals 12, right? But it's not greater than. 4 times 4 is 16. 16 is greater than 12. I've got my first yes. 4 times 5 is 20. Also greater than 12. So then what I need to do is look at this and then ask myself, well, where does my inequality become true? So as I'm looking at this, I have two options down here. So option number 1, this says that x is greater than 3. This one over here says that x is less than 3. Well, if I look at when my graph becomes true, right, it's at 4. So what that means is that my graph becomes true whenever x is greater than 3. So this is my solution to this inequality. Okay? Do the same thing for this next one. I'm going to have you just do this one on your own. I'll start it with you, but I would take negative 3 times negative 5, which is 15. Is 15 less than or equal to 9? No, it's not. Right? Negative 4 times negative 3 is a positive 12. Is 12 less than or equal to 9? No, it's not. Go ahead and finish this one up and then check your answer with me when you're done. Okay, so when you got to the end of this, you should have come to the conclusion that x is greater than or equal to negative 3. So my values start becoming true at negative 3 and then anything above that, right? All right, let's go to the next page. Maybe. Now it's asking us solve negative 3x is less than or equal to 9 by adding 3. You know what? We're going to skip this. Don't do this one. We're going to skip that for now. Or we're just going to skip it. Okay, so let's go down here. We're doing the same thing but with division this time, right? So I would have x over 3. When x is negative 1, I have negative 1 over 3. 0 over 3 is just 0. Then I would have 1 over 3, 2 over 3, a positive 1. 3 over 3 is 1. 4 over 3, and 5 over 3. So then I have to look at, is negative 1/3 less than 1? Yep, sure is. 0 less than 1? Yes. This one I would look at, is 1/3 less than 1? Yes, this one is also less than 1. This is less than 1. Is 1 less than 1? No. So this is where it starts becoming no. Is at this point. So then I look at, well, where is this true? Well, it's true in all values less than 3, right? So which one says x is less than 3? This one over here. X is less than 3. Okay, I want you to go ahead and do letter B on your own. When you're finished with it, you can come back and check your answers with mine. All right, so for this one, you should have gotten to the end that x needed to be less than or equal to -3. All right, I want to look at table 4. This might take us a little while, but this is important. So we're going to do the same thing that we have been doing with our inequality tables. I'm just going to fill in some x values here. So I'm going to start at -5 and go all the way to +5. So -5, -4, oops, -2, -1, 2, 3, 4, and 5. Okay. So what I'm going to do, this is going to take me a little while, so I'm going to do a couple with you and then I'll have you finish it out on your own and we'll talk about it after, is we're going to fill in this graph with our values. So -2x, when x is -5, so I've got -5 times -2 is 10, right? -2 times -4 is 8. -2 times -3 is 6. -2 times -2 is 4, so on and so forth. I'm going to keep going down. It's decreasing, I'm noticing, by 2 every time. So I'm just going to continue that pattern. Okay, so that's all I'm doing. I'm going to fill in all of these squares with the values when x is all of these different things. So go ahead and fill in your table, and then you can check your answers with mine when we're done, and then we're going to talk about what we notice about them all. Okay, so when you have your table completely filled out, you should have these values in your different boxes. So what I need to do is start looking at patterns. Okay, so let's start with letter A. So my inequality for letter A is -2x is less than or equal to 10. Well, let's look at the graph, our table, and figure out when is this true. So when is -2x less than or equal to 10? Well, I'm noticing that it's at 10 at -5, right? So that's when it's equal to 10, and it's decreasing every time. So I know that my solution to this is that x is, what is it? Greater than or equal to -5, right? So it's all values that are greater than or equal to -5, right? Because these are increasing at the top. If I look at letter B, when is -6x greater than 0? So now I'm looking at 6x, this line right here. So when is -6x greater than 0? Well, all of my values greater than 0 come to the left of 0. So that means that x is going to be less than 0. It's all of my numbers less than 0 are going to be true. Letter C, I have x over -4 is less than 1. So where are my values less than 1? Well, I can see that as my numbers are getting bigger, my y values are getting smaller, and so I can see that x is greater than -4 is the solution to this inequality. It's all values of x that are greater than -4. If I look at the last one, where is x over -8 greater than or equal to 1/8? Well, I see that that is happening here at -1. So, and it's all values to the left of that, which means that my solution is going to be x is less than or equal to -1. Now, we need to try to figure out a pattern that's happening here, right? So let's start with letter A. My inequality was -2x is less than or equal to 10. But my solution is x is greater than or equal to -5. So what happened between my inequality and my solution? Well, if you notice, my inequality, the sign changed. See? Oh, that kind of makes it go away. I wanted to highlight it so you could see this. But I start with a less than or equal to sign. My solution has a greater than or equal to sign. If I look at letter B, negative 6x is greater than 0. Well, my solution is that x is less than 0. So what I'm noticing, and what I hope that you are also noticing, is that when I multiply or divide, an inequality by a negative number, what happens to my inequality sign? My inequality sign flips. When I multiply or divide an inequality by a negative number, my inequality sign flips. And I can see that that's true for all of these, right? So letter C, in order to get x by itself, I would have to multiply both sides by negative 4. I started with a less than sign, now I have a greater than sign. So whenever I multiply or divide an inequality by a negative number, my inequality sign is going to flip. You'll have to commit that to memory because it's kind of hard. To remember. So then we have some practice problems here as well. I am going to go over just like 2 of them with you, and then I'm going to have you finish the rest on your own. We'll go over the word problem together though. So number 1, I have 6n is less than 90. Well, 6n I know means that I'm multiplying 6 and n, and so to get rid of my multiplication I need to divide. So I'm going to divide both sides by 6 to get n by itself. Well, 90 divided by 6 is going to give me 15. So I know that n needs to be less than 15. So I'm going to graph this down here. I'm going to put 15 here. I'm going to go up and down by 2's because there's not a lot of space. At 15, I'm going to use an open dot because an open dot tells me that I'm not including 15 in my solution set. N is less than 15 means that my arrow is going to be pointing to the left. It's getting smaller. Okay? Let's also look at number 3 together. Number 3 says negative 20t is greater than negative 80. Also a multiplication problem, so I need to divide to undo it. So I'll divide both sides by negative 20. But remember, when I divide something by a negative number with an inequality, my sign is going to flip. So when I do that, I'll have t, maybe, t is less than negative 80 divided by negative 20 is going to give me 4. T is less than 4. So if I put 4 down here, 4, 6, 2, I'm going to do another open dot at 4, arrow pointing to the left. I just remembered I had one more that I wanted to do with you, and that is number 9. Yeah, let's look at number 9. We'll do 9 and 10 together. So number 9, negative 2 is greater than or equal to q divided by negative 0.3. So to get rid of my negative 0.3, I'm going to need to multiply both sides by negative 0.3. Oops. Multiply this by negative 0.3. Negative 0.3 times negative 2 is a positive 0.6. So I have 0.6. I multiplied by a negative number, so this needs to flip, is less than or equal to q. Now, what might be kind of confusing about this, and we've talked about this before, is that we are used to seeing our variable on the left-hand side of our inequality, like number 8 has, right? We're used to seeing it on the left-hand side. And so at first, if I look at this solution, I might think to myself, well, q is less than or equal to 0.6, right? That's kind of what makes sense because I see a less than or equal to sign. But remember that our inequalities, the opening is going to go towards the bigger number. So in this case, that means that q is my bigger number. So negative, or 0.6 is less than or equal to Q is the same thing as saying Q is greater than or equal to 0.6. I've had quite a few students mix that up, and they think that it's a less than sign when it's actually not. So then if I graph this down here, if I have 0.6, I'll do a 0.8 there, 0.4. Greater than or equal to means that I'm going to use a closed dot, so I'm going to put a closed dot on 0.6 because I'm including it. It's greater than, so my arrow is going to point to the right. So that one's a little bit trickier because of that. Let's also look at number 10. To win a game, you need at least 45 points. Each question is worth 3 points. Write and solve an inequality that represents the number of questions you need to answer to correctly win the game. So I know that every question is worth 3 points. So I have 3 points times however many questions I have. So I'm going to use Q for questions. 3 times however many questions. I'm noticing the words at least. You should also be noticing the words at least. When I think of at least, that means that it's the smallest number that it can be. So to win a game, I need at least 45 points. So that means that however many questions I have times 3 points per question needs to be greater than or equal to 45. So my inequality is 3Q is greater than or equal to 45. So in order to get Q by itself, I'm just going to divide both sides by 3. I'm left with Q needs to be greater than or equal to 45 divided by 3 is 15. So I need to answer at least 15 questions correctly in order to win the game. All right, I would like you to finish the rest of this on your own. And if you have any questions, let me know.